All right, so this is part 2 of week 2, lesson 2 for math. All right, so creating multiple representations of equivalent algebraic expressions, that's the objective. So this is now on worksheet, the second worksheet. So if you see this is the first one, this is the second one. All right, so again, we're working with models and equivalent expressions. So if I look, suppose there's a rectangular shaped banner that has an area measuring 70 plus 42y square inches. Describe how you would determine possible dimensions for the banner. So dimensions, if you guys forgot, it means the length and the width. So what I always think of doing is I want to think of a picture, because if I'm looking at geometry, I want to think of a picture. I'm going to insert a drawing just like in the last video. And I think it was 70 plus 42y. So I'm going to insert shape rectangle. The area was 70 plus 42y. So I'm going to split my banner in two pieces because I have 70 plus 42y. I don't know how big they are, so I'm just going to estimate that 70 is bigger than 42y. I don't know that, but it's fine. I'm just going to put it that way. In algebra, it doesn't really matter. All right, this is 70, and I'm going to insert 42y. Okay, so thinking of the distributive property, what do both of these have in common? What's the greatest common factor? Yeah, my common factor is probably 7. So I'm going to insert a 7. So meaning I think the length would be 7. And my width of this first section, can I let you guys think for a second? If you guessed it's going to be 10, you are correct. 10. And 7 times, here's the tricky part, 7 times how much is 42? And where did I get the y from? So I don't know what y is. So I'm just going to leave it at y. I'm going to do 10 plus 47 times 6. So 6y. So if I do 7 times y, I'm going to get 7y. So 7 times 6y, I'm going to get 42y. So that's where I got that. So that means the length of this banner is going to be 7 long and 10 plus 6y wide. Those are my dimensions. I'm going to draw a picture. This is my picture showing that. All right, this is going to help me out a lot because since it's a rectangle, I know since this is 7, this is 7 as well. Since this is 10, this is 10 as well. This is 6y, this is 6y as well. All right, so how I did that, I drew a rectangle and I showed the area and used distributive property to find the length, width. Right. Because the length is 10 and 6y. 10 plus 6y. And then the width is 7. I might have switched it, but it doesn't really matter. I just know this is 7, this is 10, and 6y. All right. So I'm going to make this bold because this is my answer, or I can just change it to color. It doesn't matter. All right. What are two expressions that are equal to 70 and 42y? Okay, we already have one. It's 7. I don't want a letter. 7 times 10 plus 6y. But it's asking for 2. What's another common factor between 70 and 42? I'll let you guys figure that out, but it doesn't always have to be the greatest common factor. So 7 would be the greatest. What else is something else that both 70 and 42 both have? Thinking they're both even numbers, that's a clue. If they're both even numbers, a common factor would be something. I'm not going to say it. All right, create a model that supports all three expressions are equivalent. Okay, so probably just copy and paste this over here, and probably make more. I don't know. I know this inside is going to be the same for all three. So therefore, how can I edit this? I mean, it's going to be different depending on your equations, but you should all have the inside that's the same. All right, let me see what else this is asking. Is equal to this. Huh. What do you think? This is 70. This is 42y. What do you think they did to make this? Do you think it's correct? Huh. I'm not going to say. You guys figure it out. Because based on this, I know the 70, but do we really know what this y is? If this y is 1, that means this area is 42. If this y is 2, that means y times 42, that'd be 84. Can I really add this into here and say that I have, what would it be, 112 y's? Huh. 112 times y would be very different than what I got here. Huh. So think about this. What does this mean? What do you think this means? So draw a picture. What do you think it means? It could be, you can do the area, doesn't matter. Create a model to represent this. Okay, you can create another area model. What does this mean? I have 5 times whatever's inside. So think about that and describe how the model in 3 would represent this plus this. Oh, how might I change it? Could I add something to it? It's interesting. I like this question. All right. Oh, there's more. Wow. Okay. Well, anyway, this is a little bit longer. Try your best. This is the same thing as what we did in the previous worksheet. All right. Anyway, try your best on this. You don't have to do the entire thing. If you get stuck, make sure you ask me a question. But again, I'm not requiring you to do any of this. This is on your own practice. If you care about your learning, this is what you should be doing. All right.